We have just looked at a case where the conductor is in the form of a closed loop. That is, if you are bringing the bar magnet close to this loop, then there is a EMF that is developed, and because this is a closed loop, a current can flow. But now let us look at a case where it is just a wire basically. It's not connected at both ends, so a current cannot flow. Then let us assume that there is a magnetic field. You can see in this slide, it's pointing into the page. And then let us assume that we are moving this wire in the positive direction towards the right with a constant velocity v. Now this is just a piece of wire, so a current cannot flow, but the wire is a conductor and it has positive and negative charges. And let us analyze the forces that are acting on these charges. So let us apply the formula Q V cross B. This gives us the force exerted by the electromagnetic force basically acting on the particle. So V is to the right, B is into the page, and so let us apply the right hand rule. V pointing to the right, B is into the page, and so a positive charge experiences a force, an upward force basically. So a positive charge moves to the upper end of the bar. Now what happens to the negative charges in the conductor? So for the negative charges, Q is negative, so we have to reverse the direction QV. So applying the right hand rule again, we see that there is a force directed downward on the negative charges. So the negative charges are moving to the other end of the bar. So the positive charges are then located at the top of the bar, and the negative charges at the bottom of the bar. So you can see there is a potential difference between the two ends of the bar that has developed, but a current is not flowing in this case because the wire is not connected at both ends. And this slide shows the positive and the negative charges at the two ends of the bar. And now suppose we just suddenly stop the wire from moving, we decrease its velocity to 0, then what happens? Then actually the charges will disappear, right? Because there is no force keeping the charges at the two ends again. So they will, because this is a conductor, charges can flow freely, so they will neutralize each other, and the bar will again be neutral locally. So the charges are no longer located at the ends of the bar, ends of the wire. So this is basically to demonstrate that an electromotive force is developed whenever you have a conductor moving in a magnetic field. It doesn't have a closed loop. If it is a closed loop, a closed circuit, then in addition you have a current flowing because there is an electromotive force that drives that current basically. All right, so hopefully this is clear to you now.